Hey, good afternoon. Either grab your notes or grab a spot at the board. I want you guys to try number 7. This is a review from last week. If that's what you prefer, that's fine. Working on number 7, either in your notes or on a board. With this, I want to run through this again. At this point in the game, I don't know that you can see too much factoring. I think the more you see it, the more you do it, the more you hear it, the more you experience it, the better you're going to get. So what I'm going to do is I'm just going to go one at a time here. I'm going to try to factor that first one, upper left hand first. The first thing I should always ask myself when it comes to factoring, is there a GCF? So with those 3 terms up there on the upper left, do you see a common factor I could get out of all of them? No. But it is a trinomial, so maybe that'll work. To do a trinomial factoring, I need to figure out my AC. My AC would be -3. My B is -2. So the numbers that work in the X would be -3 and 1. Does it make sense? Mm-hmm. Okay. So then what I'm going to do is I'll split the B with that. So it'd be x squared minus 3x plus 1x minus 3. I always group my... Group those and add. Group the first 2, group the second 2 and add. You guys see the GCF in the first one is x. Leftovers is x minus 3. What could I technically factor out of the second grouping? It's a little strange, but what technically comes out? 1. A 1 technically, right. So it would be plus 1 and then x minus 3. And then I factor out my x minus 3s. By the way, at this point I'm not factored yet, but when I do factor out my x minus 3s, I am fully factored on this one. X minus 3 times x plus 1. So what I'm going to do is I'm going to replace this with that factoring. So that would look like this. X minus 3, x plus 1. You guys have any questions on that factoring right there? Okay. So the next one, I'm going to erase all this stuff over here. The next one is not going to take nearly as much space. Please keep in mind the first thing you should ask yourself if you're factoring is there a GCF? So when you look at this lower left, is there a GCF? A 2, that's right. So I want to factor out that GCF. It is a 2. The leftovers would be x plus 2. And if you didn't think about that GCF, you might have gotten kind of stuck on this one. But if you do think of the GCF, at this point, it's done, right? That's all we can do with the factoring there. And then something similar here with the upper right, x squared minus 4. It's not a trinomial, and there is no GCF, right? But if you look really carefully and you notice the different characteristics of it, this one even has a special name. Do you remember what this one is called? Yeah, the difference of squares. Difference of squares. And so it's going to factor with that plus minus pattern, x plus 2, x minus 2. Still good? Any questions? Okay. And then lastly, we have this trinomial here. There's no GCF, so I'm not going to be concerned about that. But I will try to factor the trinomial as it stands. The trinomial is x squared plus 3x plus 2. So the AC is 2 and the B is 3. Did you guys come up with 1 and 2 for those two numbers? 1 and 2. Okay. So that's going to split the B like that. X squared plus x plus 2x plus 2. Group and add. Factor out the GCF. X times x plus 1. The other GCF is 2 times x plus 1. So your final factoring would be x plus 1 times x plus 2. That goes here. Okay, so that's all of it factored. Do you have any questions about any of the factorings? There's 4 of them up there. Okay, so isn't it true that once you factor, then all the items that cancel out become a lot more clear, don't they? So as I start to look to cancel things out, I see x plus 2 canceling with x plus 2. I also see x plus 1 canceling with x plus 1. Do you guys see any other cancelings? Hey. Anything else? What about this one? What about this 2 canceling with that 2? Why not? Yeah, it's the whole minus thing, and I'm only taking out part of this one, right? You can either cancel out the entire factor or none of it. So you're right, that would be a bad move. How about this one here with this one here? That x with that x. Same reasoning, right? You can't cancel out part of the factor. It's got to be the whole thing or none of it. So maybe this is it. So if I were to try to write the answer, I would multiply my numerators together. That would give me x minus 3 times x minus 2. And then down in the denominator, it would be 2 parentheses x plus 2. You guys see any other cancellations here? Because I've got to simplify this all the way. Can any of those x's cancel out with each other, you think? Any of the 2's cancel out with each other? I mean, I'm looking at this. What about this? This looks pretty good to me. Shouldn't those 2's cancel out? They're right above each other. For real. Can I do that? Why not?
Because they have to be together.
It's got to be the whole thing. It's got to cancel the entire factor or none of it. Do you see how I'm only canceling part of a factor? Just a little bit, just the 2's, not the x's. That's not going to work either. So this is it. That's my final answer. Walking around, I saw quite a few of you had that. So that's obviously encouraging. Do you have any final questions before we move on? Victoria. So when you say simplify, are you talking about maybe like FOIL?
Yeah.
You certainly could, and I would never mark you off for that, but you don't have to.
Okay.
You don't have to at all. I kind of like leaving it this way because you could, like if you didn't see a cancellation, you maybe would see it here. So I wouldn't, I don't know that I would do it. It's just extra work, and you're not going to get any other credit for that. So I'd probably just leave it like that. Great question. Anybody else? Okay, fantastic. All right, so if you grabbed a little whiteboard, which it looks like a lot of you did, would you guys please nicely take those back over there? Grab your notes. We're going to push forward and finish up addition. We have 3 examples, and we're going to spend some time practicing and reviewing for our quiz coming up. Wednesday. Wednesday is it? Please get here in your notes.
We practice at the Pepsi Center.
Okay. Thanks. Hey guys. So I want to remind you what we did last time. This was last Friday. We talked about how what you guys did a nice job of here today warming up was multiplication of rational expressions. We've done some division. We'll probably do a little bit more division before the day is out. And so naturally addition and subtraction would be a logical continuation of this. And we did 3 examples of addition and subtraction on Friday. And so we're going to continue on with that today. But this time, we don't have those nice common denominators to start off with. So when you look at this one, you've got a denominator of 11 and a denominator of 3. So they're obviously different denominators. And so what we want to think of here, this is no different than what you did back in like 6th, 7th grade, trying to find common denominators. We want to think, what is the smallest number that 3 and 11 both go into? Any ideas on that? 33, that's right. And so what I'm going to do is I'll write my fraction over here. It's 4a over 11 plus 2a over 3. I'm going to give myself a little bit more room here. And I need to realize that both my denominators need to be 33 in order for them to be a common denominator. So what do I need to multiply the 11 by to get to 33? 3. Remember that when you're working with fractions, you are definitely allowed to multiply the denominator by something as long as you multiply the numerator by the exact same thing. So if I have to multiply the denominator by 3, I've got to multiply the numerator by 3 also. With the other fraction, the one that has a 3 for the denominator, I want it to be a 33. So what do I need to multiply that one by? That's right, 11. So if I'm going to multiply the denominator by 11, I have to multiply the numerator by 11 as well. I want you to think about it for a second. What is 3 over 3? 1. It's 1. So technically, aren't I just multiplying by a smart 1? like a strategic 1. What's 11 over 11? 1. So I'm just multiplying by 1. My point with that is simply to say I am not changing the value of the fractions at all. I'm simply multiplying them by 1. I'm just changing the form. You want to find that common denominator, make the necessary adjustments, and then we'll add. So here's how this would look when I do multiply 4a times 3. What would 4a times 3 end up being? 12a. Still over 33. And what about the other one?
22A.
22a. That's right. Still over 33. Now let's remember, when you add fractions, you add the denominators?
No, you
Oh,
can't.
they stay the same.
They stay the same, right? So this is going to end up being something over 33. And what do you do with the numerators?
Add them together.
You actually do add them. So what is 12a plus 22a?
34.
It is 34a. There's always a temptation to write something like 34a squared. Remember that a times a is a squared, but a plus a is just 2a, or in this case, 12a plus 22a is 34a. There would be no squared on the a. This would be our final answer for this one. And we're done. What do you guys think? So, can I give you guys one that kind of looks like this that you can try by yourselves? Okay, so I'm going to erase some of my work here. Maybe I'll just write this over here, 34a over 33. I'm going to split my screen, and I'll give you a different one that looks sort of like that. Let's go with 5a over 12 plus 7a over 8. Yeah, I like that one. Why don't you guys give that one a shot? I'd like to show you guys a couple of thoughts here. And as I'm walking around, like the big difference basically has come down to what is your common denominator? How many different common denominators could you come up with for this one?
33.
There's actually an infinite number of ways you could get a common denominator. You'd never come to an end of that list. The point is this: I think it's most efficient if you can find the lowest common denominator. So the smallest number that both 12 and 8 go into.
Oh, 12.
So 12 and 8, I mean, don't both 12 and 8 go into 96?
Yeah.
Because 12 times 8 is 96. Don't 12 and 8 both go into 48?
Yeah.
They really do. But what is the smallest number they both go into? 24. 24 is it. So if I'm looking for 24 for a common denominator, what I'd need to do is I'd need to multiply this one by 2, top and bottom. And over here I'd need to multiply this one by 3 for the numerator and denominator. So you can you could just go, like if you're looking for a common denominator, you can just go 12 times 8 and that's the common denominator. But that will sometimes not be the lowest common denominator, which is going to make you do a bunch of reducing on the back end when you get there. Nothing wrong with that. This maybe just makes it easier. When I multiply these two together, I get 10a over 24 plus 21a over 24. Adding these together, I get 31a over 24. Okay, so a lot of really quality answers along those lines. Do you have any questions? Go ahead, Grace.
So if there's like a variable with like the numerator, you don't have to like reduce it, because like if there was like not an a there and it was just 31 over 24, wouldn't you change it to like a mixed number?
I don't think I ever really would want you to do a mixed number, to be honest with you. I think I prefer improper fractions every time. But you could, I mean, if you wanted to say that this was 1 and 7/24 a, you really could. I think that really complicates the issue, so I don't think I would do that, but you could. Any other questions? Okay, awesome. Let's move on to number 5 then. I want to help you out with a little bit with number 5. It is a subtraction problem, I think. There we go. Okay.
No, I have to ask you something. I was trying to get you.
So guys, this might be a little more challenging. So I'd like to work through this one with you. And then I'll give you a chance to do one on your own, kind of like we did last time. So I'm looking at my two denominators. Are they the same?
No.
Definitely not. And this time the denominators have x's in there, and so we're going to have to consider that as we move forward. But what I would like to do for the moment is think only about the numbers. Let's deal with the x's in a second, but let's think this through. Feel free to use a calculator if you want to help you. But with the 30 and the 36, what is the smallest number that both 30 and 36 evenly go into? Any ideas? 30 and 36. What's the least common multiple or the lowest common denominator?
190.
Nope. 180. That's it.
I did that.
180.
So close.
You were close. Yep. 180. So, just as a little... Hey guys, I'm going to ask for your full attention. I'm just going to do this a couple minutes. You'll have a chance to work on your own. Remember, that's how this works. So least common multiple, 180. Totally agree. But then we got to think about the x's. I've got x squared and I've got x. What is the least common multiple for x squared and x? It's actually x squared, right? X squared, because both of them, one of them has an x, the other one has x squared. So a multiple is always going to be at least as big as the biggest or the bigger number. So x squared being bigger, we're going to have 180x squared for that least common multiple, also known as the lowest common denominator. So now what I've got to do is I've got to think, how am I going to multiply this out in order to get this common denominator right? So let me just rewrite this real quick, like so. Okay, any ideas? What do I need to multiply 36x squared by in order to get 180x squared? Go ahead, Jake. I'm not worried about this one at all right now. I am only concerning myself with this one. I want that denominator to be this 180x squared. So what do I need to multiply by to make that happen? 5. Yep. So if I take this left fraction and I multiply the denominator by 5, whatever I do to the denominator, I've got to do the same thing to the numerator. So I'm going to multiply the numerator also by 5. Again, I'm multiplying by a smart 1. This will get me to my common denominator. The other one's a little trickier. What do I need to multiply? Now I'm working on this one. What do I need to multiply that denominator by to get to 180x squared? 6x, right? Because aren't I missing an x as well? Yeah. So if all I did was multiply by 6, which is not a bad move, if I multiplied by 6, wouldn't I get 180x? 6x. Well, 6 times 30 is 180, right? So 6 times 30x would give me 180x. I need another x to make that happen to get me to my 180x squared. So I'd have to multiply the top and the bottom by 6x, not just 6. Does that make sense? Okay. So then to finish this one off, what I need to do is I need to go ahead and multiply. So I get 35 over 180x squared. Over here it's 66x over 180x squared. And then my final step would be to write 35 minus 66x over 180x squared. Could I do 35 minus 66x and get negative 31x?
No.
Why not? They're not, what's the right word?
It's not like
Compatible, I like that. They're not like terms. They're not compatible either, whoever said compatible. You're right, Paige. They are not like terms, and so they don't add up. They don't combine, I should say. And so this right here would be it. Okay, so you guys ready to try one on your own? Okay, so let's try this one. It'll be similar. Let's go with 5 over 24x minus 7 over 18x squared. All right, give that one a try. Real similar to the one you just did. Hey guys, so walking around, here's the answer that I saw from the vast majority of you. Hey guys, will you take a look at what we have up there? Look at what you have, look at what I have. Is that what you have as well?
28.
Yes. Oh,
7.
maybe we
I
have,
left it as 7.
do we have anything we need to talk about?
No, I left it as 7.
Did you guys get that too?
Well, at first we did 144 because we thought that was the highest or the lowest, but
Let's-
72. So.
You know what? Hey guys, hey, listen up, please. Hey, let's talk about this because you bring up a really good point. What if you did not see the fact that 72 is the lowest common denominator? What if you did something bigger? Like you said 144, I think you could have gone even bigger than that. So if you did that, let's say to get to 144, you'd have to multiply by 6, top and bottom. And over here, you'd have to multiply by 8, top and bottom. So if you did it this way, let's think about what would happen. You would get down here and you'd say 30, 7 times, or I guess it'd have to be, 6x. There we go. So you'd say 30x minus 56 over 144x squared. So if you got to that, I would say that you've done a lot right. You found a common denominator. You made the necessary process to get to that, and you've combined them correctly. You just don't have a simplified answer. What could I do with this to get it back down to that answer that we know it should be?
Simplify.
Simplify it, and if I'm going to simplify, what do I have to do first?
Find a common factor.
I've got to factor it. So that's that old phrase I've been saying, I think, just about every day. If you're going to simplify a rational expression like this, you have to factor first. The denominator is more or less already factored. It's already a multiplication problem, but the numerator isn't. What's the common factor that I could, like Jake said, what's the common factor I could bring out of the numerator? What's in common between 30 and 56? Come on, think. What goes into both? For sure. They're both even. 2. So couldn't you say 2 parentheses 15x minus 28 over 144x squared? And then this 2 would cancel with the 144 to make 72, giving us that answer that we already had that was most simplified. So you could definitely do it that way. It's okay. Just make sure you go back and see if you need to reduce. All right. Any other follow-ups? Nice. Okay, let's move on to our final question of this section here. And then we'll just be practicing after this. Here we go.
Because I just heard shoot.
Hey, let's stay focused. Stay focused on the math, okay? Thanks. Okay. So with this, we look at our two denominators, and if we're going to be adding or subtracting fractions, the denominators have to be exactly the same. Are they?
No.
They are not. One of them is an x plus 2. The other one is an x minus 6. And I'm just kind of curious to see what you guys think about this. What do you guys think the least common multiple or the lowest common denominator would be for those two denominators? So just a single 6 with no x.
An X and a 6.
So 6x.
Yeah.
Any other suggestions?
Could you just FOIL it?
Foil what?
The two denominators and put it 5 over.
That's totally different than this, right? Okay. Your idea is not far from the truth. I don't know that I would go that far, but I think it's pretty good. Let me ask you this. You're gonna want to see this for sure. So, like Haley, you're just like, I don't know what you're writing, but you're gonna want to see this. Okay. So 6x is definitely not the common denominator.
Homework.
I'll take care of it. Appreciate it, though. So 6x is definitely not the common denominator. Let me put it to you like this. Let me see if I can give you a parallel example. I'm going to erase this, so please don't write this down. If you had something like, I don't know, 5/11 plus 3 sevenths. Obviously much simpler. Isn't 11 prime? And 7 also prime? So if I was going to come up with the least common multiple between 11 and 7, what would you do? Multiply them together. It would be 11 times 7, right? 77. So let's go over here. X plus 2. How could we factor x plus 2? Gentlemen, how could I factor x plus 2? No, don't worry about the x and the 6. I just want to know, how could I factor this right here?
You couldn't,
Why?
because they're not like a term.
Because it's prime. X plus 2 is already prime, isn't it? Kind of like the 11. What's the factors of x minus 6? Isn't it already prime? So, over here, you guys told me that if I have a prime denominator like 11 and another prime denominator like 7, the least common multiple, or the common denominator, would be 11 times 7. Over here, I've got a prime denominator and another prime denominator. What would you guess the least common multiple would be?
Multiply.
Those two multiplied together. Just like we did 11 times 7 to get that one, we would do x plus 2 times x minus 6. What you're tempted to do, I want you to think about this. What I think you're tempted to do is to ignore the x completely or partially, look at the 2 and the 6 and say, well, 6 is the biggest number that they go into, and let's just tag an x on there to begin with, or maybe just in the end just because it's there. Keep in mind that just like we talked about before, remember how you guys cannot cancel? You guys were really vocal about this. Remember how you guys said that you can't cancel this 2 with this 2? And you were right. You totally were. The same way, you can't look in here and be like, well, I'd like to take this 2, and I'd like to take this 6. I'd like to take part of the factor and do some work with this part. And then, you know what, we better just throw an x in there because there was an x in there. Can't really do that. We got to take that x plus 2 as a whole factor and the x minus 6 as a whole factor. And they really are different, right? They are not the same, and so they're prime. And so we need to find the least common multiple. We just need to find the product of those two. And so, Jake, this is where I come full circle back around to your suggestion and say, yeah, least common multiple is going to be x plus 2 times x minus 6. It's just going to be the product of those two prime denominators. Does that make sense? I was hoping you'd see the parallel with those two. So, when we go to actually do this, let's think about how this will look. If my goal is to have this as my denominator, for the first fraction, what would I have to multiply by? Isn't x minus 6 the thing that's missing? So I'm going to multiply the first fraction, denominator by x minus 6, and the numerator also, times x minus 6. For the second fraction, what would I need to multiply by? X plus 2. That's what's missing. So I'm going to multiply by x plus 2 and x plus 2. And again, like before, I ask you, if you divide something by itself, isn't that just another way of saying 1? So I would propose that that and that are just fancy 1s. So again, I'm not changing the value of the fraction, just changing its form. We'll practice with this here in just a second. Let's think about how the details would work. Oh, sorry, I heard a what the heck. So go ahead, proceed. Expand on your what the heck.
I'm just super lost.
Tell me where.
Like when you had the ones.
Okay, so let me go backwards because Alec just said everywhere. So let me trace back and let's find out exactly where you're confused. Are you guys okay with this being our least common multiple?
Yeah.
Alec,
Yeah.
for real?
Yeah.
Okay, so you're not confused everywhere. You're okay with that. Are you guys okay with the idea that when you look at this first fraction and we want our denominator to be this, do you see how in the denominator the factor that's missing is x minus 6?
Oh, I see.
And so in order to get this, don't I need to multiply by that? Does this make sense? But with a fraction, you are not allowed to mess around with the denominator at all unless you do the exact same messing around with the numerator. So if I need to multiply the denominator by that, don't I have to multiply the numerator by that? And you see, basically what I'm doing is I'm multiplying by a fraction, x minus 6 over x minus 6. And so my point with the ones was simply to say I'm multiplying by 1 And what happens when you multiply by 1? It's the same thing. And so I'm not changing the value of the fraction. It's not becoming some brand new fraction. Its form is just changing. Oops, there we go. So you don't have to write the 1 in there. I'm not that worried about that. I just want you to realize that we're not doing any magic here. We're simply multiplying by a really strategically formed 1 in order to generate the correct fractions to add. Where are we at? So Alec has gone from confused on everything to good. What about you, Jake? You're good? Okay. Any other questions? Okay. Do you guys see here, let me give myself a little more room. Do you guys see the distributive property here? Okay. So 5x minus 30 over x plus 2 times x minus 6. And then do you guys also see the distributive property there? What happens when you distribute that 3x? I'd like to hear from you guys. 3x squared plus 6x. That's right. Okay, so then my final step is going to be to go ahead and actually add these together. We're going to be looking for like terms. Is there anything like the 3x squared?
No.
Nope, there isn't. So we're going to write it as 3x squared. Is there anything like the 5x? 6x, yeah. So 5x plus 6x is 11x. And then there's nothing like the minus 30. So we'll write this as x plus 2, x minus 6. And we'll often want to check to see if this reduces. I'm going to save you a little bit of time and tell you I don't think this does. I don't think so. I don't think so. So we leave it as is. Yes, ma'am.
So I'm so confused why you wouldn't like FOIL the denominator.
You could.
Oh,
Yeah, it doesn't make any difference to me if you do or don't. I suppose maybe I would sort of prefer that you didn't, simply because, you know, if you were going to find something that canceled, you'd want it like that. But if you do it correctly, no problem. No problem at all. Anything else? Okay. So I checked in your guys' 7.2, which you guys did a pretty nice job with. 7.3, 7.4 is not due until tomorrow night. So what we're going to do here for the next like 10, 12 minutes is we're going to practice that sort of thing, or some of the other stuff we've been doing. So why don't you grab a little whiteboard, head up to the big board, or if you just prefer to work on paper, you're welcome to do that too, okay? Let's do some practicing.